So here we're going to do problem 39 in chapter 4. So what we're told in this problem is that we launch a projectile over here at a 30-degree angle, and it spins 20 seconds in the air. So that's going to assume that it's going to take 10 seconds to get to the top. And at the top, we know that the y speed is going to be 0. It's still going to be moving in the x direction, but its y speed is going to be 0. And we have a number of questions that we're supposed to answer about this problem. The first question is the initial speed of the projectile. So we want to find, in part A, v0. Well, we know that the y speed at the top is 0. And I've chosen to arrange things where up is the positive y direction. So my acceleration in the y direction is going to be minus 9.8 meters per second squared. So if I just look at my y speed equation, I know at the top the speed is 0. The initial y speed is unknown. And my acceleration is negative 9.8. And it's going to take me 10 seconds to get to the top. So that means that my v0y is 98 meters per second. I can then go over here in my really poorly labeled diagram, and now I know that the y speed is this side over here, and I have a 30-degree angle. So if I'm trying to find v0, then v0 is the opposite side of a triangle. So the sine of 30 is going to be v0y over v0. So v0 is v0y over the sine of 30, and that works out to be 196 meters per second. So the launch speed is 196 meters per second. In part B, we want to know the maximum altitude. So if I want to find the maximum altitude, that's the height at the top, I can use the y equation. And now if I'm starting on the ground at 0, and I'm starting at 98 meters per second, and I'm going to go to the top, and that's 10 seconds later, so 1/2 minus 9.8 times the time to the top squared, times 10 squared. So I can just plug in all the numbers and compute that the height to the top is 490 meters. Now in part C, they ask me to find the range. So the range is the distance in x when you've gone along here. And I know that it's launched at 196 meters per second, and over here would be my v0x, and this angle is 30 degrees. So the range delta x is v0x times t, and v0x is going to be v0 times the cosine of 30, which is going to be 196 times the cosine of 30, and so v0x works out to be 169.7 meters per second. And then I'm in the air for the whole range. I'm in the air for 20 seconds. So delta x, the total range, would be 169.7 times 20 seconds for the entire range, and that works out to be 3,390 meters for 20 seconds. In part D, we're told that we want to find the displacement at 15 seconds. So the x equation is going to be x0 plus v0 xt. So that's 0 plus my v0x was 169.7 times 15. So in x, it has traveled a distance of 2,500 2,546 meters. And then in the y direction, again, it starts on the ground. The y initial speed was 98, and now I'm thinking about this for 15 seconds. 1/2 times the acceleration, which was downward, so I'm using up as the positive direction, so down is minus 9.8 for the acceleration. And I see that the y distance traveled is 367.5 meters. And so as a vector, I might say the displacement vector is 2,546 meters x hat plus 367.5 meters y hat. Or if I wanted to find the magnitude of that vector, I have 367.5 on this side and 2,546 on this side. And so the d is going to be the square root of the squares, sum of the squares. And so when you plug those numbers in, you get 2,572 meters as the total displacement at 15 seconds.